So by now you know the trigonometric ratios, sine, cos, tan. Even if you don't know the other stuff, it's okay. But just in case you want to, remember it, 1 over sine is cosecant, 1 over cosine is secant, and 1 over tan is cotangent or cot. And you don't see those buttons on the calculator because they're just reciprocals. So if you want to actually take 1 over sine or cosecant of an angle, you do the sine, get the answer, and then put reciprocal, and that's it. There's a reciprocal button on your calculator. There's one single push, and that's it. You get it. You see the reciprocal button? Try to explore all the buttons on the calculator. So that's something that will really help you. Do you see the reciprocal button? Not yet? What? Do you see it? Right there. Look at that. This one.
Oh, I thought that was a cycle.
No. Reciprocal. X to the power of -1. That's your reciprocal. So if you want to just get some answer, like 25 divided by, I'm just showing you, 100, and you got 0.25, and you want to find the reciprocal of that answer, just push the reciprocal button, and it says answer to the power of -1, enter, and you got the reciprocal. You don't have to just copy the whole thing down. So there are lots of such buttons that actually can be very handy when you're doing calculations. So try to use them. Got it? Okay. So if you want to get cosecant 30, so what you do is 1 over sine 30. So instead of doing that, you do sine 30, get the answer, push the reciprocal button, you got the answer too. Right? Yeah, so those are the trigonometric ratios, but remember which one is what? Sine is opposite over hypotenuse. Cosine, as a co stands for adjacent. So cosine of an angle is adjacent over hypotenuse, and tangent is opposite over. Yeah. And you can see that also sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. If you divide both these together, you get sine theta over cos theta, which is equal to O over H times H over A, and you get O over A, which is tangent. So tan of an angle is sine over cos. You might have come up with this identity, but just make sure that you know this. So if you want cotangent, it will be cos over sine. So if you have two things, and then if you divide cos over sine, it will be a cotangent, which is adjacent over opposite. Yeah, just be fluent in how to connect the ratios with the names, because you will see all the names coming in. And those who have done trigonometry, you also might know this. Sine square theta plus cos square theta is equal to
1.
Why is it 1? Why is it 1? You learned it as an identity, but why is it 1? Is it always the case? Like sine square 10 plus cos square 10? By the way, you should also know this, for those who have not taken trigonometry yet. Why is a square put inside here? Why can't you put it there? Because if you put sine theta square, it can be often misunderstood as sine of theta square. And that is why, to avoid that confusion, we put sine square and then theta. Theta is the angle. So this simply means sine theta whole square. This is what it means. That's why the 2 goes there. So if you want sine cube, sine theta the whole cube, it will be sine cube theta. Okay? But for sine to the power of sine theta to the power of minus half, we don't write sine inverse theta. We don't write that because this notation itself is trying to kind of work backwards on the sign. Okay, this is sine inverse. So you have an inverse button on the calculator. You push second function sine, you get sine inverse. And if you're putting anything after that, that is considered to be the ratio itself. It is not considered to be the angle. Whatever you put here is going to be considered as the ratio, and it will spit out the angle for you. Say, for example, if you have sine of 60 is equal to 0.866. If you want to get the angle, imagine you don't know this angle. Imagine you don't know the angle and you want to find out the angle for which the ratio is this. So all you do is press the second function sine, so immediately this will come up. And then put the ratio there, 0.866. And you get theta, which is 60. So you can try it out in your calculator and see if it works right. Everyone should try it, otherwise when you're solving a problem, you may end up having issues such as this. So you have the ratio and you want to find the angle, you work backwards like that. You use it so many times. Sine inverse of the ratio, this is the ratio, will give you this. Try it out and see. If it's not coming out, it probably is because your calculator is in the radian mode. Okay? If you are having a radian mode, the answer that's going to come out is going to be in radians. We'll learn more about radians and conversion of radians to degrees and all that in a later chapter. Okay? So another one, tan of an angle is radical 3. So what is the angle? The angle is going to be tan inverse of radical 3. What's the answer? What's the answer? Huh? 60. So that is 60. I explained to you why is sine 0 0 and cosine 0 is 1 and sine 90 is 1 and the cosine 90 is 0, right? And tan of 0 is 0 and tan of 90 is tan of 90. I think I listed that. Infinite. Tan of 90 is infinite. So we saw that one. And some of these are, I'll work on that one later. Some of these angles are, some of these ratios, you can actually obtain it by simple methods. So I'll show you how you can get some special angles ratios easily done. You don't require a calculator for that. That's why in ACT math, they say clearly, you don't require a calculator, but if you feel comfortable, okay, use it. You don't really need it. You can, the angles that they normally give are not like complicated angles. They are special angles. Now the special angles are 0, 30, 45, 60, and 90. Those are special angles. Those are special angles. And those sine, cos, and tan of all these things can be easily written down. And how you write it down, I'll show you this. You know about zeros and 90s, right? Zeros and 90s are clear. So you don't worry about them. We are concerned about these. So how we do this? To find out those things, let's say, take a square of side 1. Take a square of side 1. And this is a 90-degree angle. If I join this diagonal, what angle is this? And this one is also 45. Okay? So now focus your attention only on the triangle that we got here. If this side is 1 and this side is 1, what is this? What's that? Radical 2? Yeah. Now let's look at this angle. What is sine 45? What is sine? Opposite over? And here is the opposite. And here is hypotenuse. So that's your answer. Sine of 45 is 1 over radical 2.
Is that fine in physics?
What is that?
Answer.
To keep it like that? Yeah. You need the final answer. So once it comes to the final answer, don't leave it in ratios or don't leave it in radical signs. Pull it all here. But this will actually help you to kind of quickly process the problem because you can use this and enter this as it is on the calculator. Sine 45 is this. Cosine 45 is what? Adjacent over? Which one is adjacent to this side? And so cosine 45 is adjacent over. So whether, because it's an isosceles triangle, doesn't matter. Sine 45, cosine 45, it's going to be 1 over root 2. It's always the case. And if you rationalize that, you know what is rationalizing, right? If you rationalize this, 1 over square root of 2 times square root of 2 over square root of 2 gets you square root of 2 over 2. And square root of 2 is 1.414. So divided by 2 gives you 0.707. And you'll see that I use it kind of very. So both of them, the value of this is going to be 0.707. You can try all these things instantly on your calculator and see if the answer, 1 over square root of 2, is it 0.707? So you can actually kind of use it instead of wasting time. Tan 45. It is opposite over adjacent. Opposite over adjacent, that is tan 45. So 1 over 1, which is 1. Tan 45 is 1. Okay? Tan of an angle is basically the opposite side over the adjacent. Later on you'll see that that is pretty much what we do to find the slope of a line. The slope of a line is rise over run. The rise is your opposite side and run is the adjacent side. Okay? Just keep all those things. Now, so 45 degree, you have this to get you all those numbers. And once you know what exactly is 45 degree, and that is 1 over radical 2, 1 over radical 2, and 1, you don't have to even draw the square anymore because that should stay in your mind. As soon as you see 45, you say, oh, sine 45 and cosine 45 both 1 over square root of 2, and tan 45 is 1. It's over. You don't have to sit and memorize it. It's already understood. For the 30 and 60, you draw an equilateral triangle. What is an equilateral triangle? All sides are equal and all angles are 60s. So this angle is 60, 60, and 60. Take this equilateral triangle. Now you're going to take each side as 2, 2, 2. Take each side as 2's, not 1's. It's okay to use 1's also, but 2's are more friendly. Now split this into 2. So your right angle is coming out there. Right angle is coming out there. So what is this side now? 1. So look at this triangle. This is 1. This is the longest side, which is hypotenuse, which is 2. And what is this one then? So what do? The longest side square minus one of the legs square, radical. So 2 square, 4, minus 1 square, 1, will be 3, and then take the radical of 3. Radical of 3, that's it. So that is radical 3. So you got the sides. And focus on this triangle now, only on this triangle. And you can say, what is sine 60? Sine is opposite over, so it is radical 3 over 2. What is cosine 60? Cosine 60 is adjacent over, adjacent is 1, hypotenuse is 2. So it is tangent 60. Tan 60 is opposite over adjacent, which is just radical 3. Same way, sine 30. Now that is your angle 30. That's your angle 30 because you split it into 2, right? So for this angle 30, what is sine 30? For this angle, where's the opposite side? For this angle, where's the opposite side? Yeah. For this angle, where's the adjacent side? Radical 3. So keep that in mind. Sine 30 is going to be opposite over hypotenuse. Cosine 30 is going to be adjacent over hypotenuse. Adjacent over hypotenuse. And tan of 30. Tan of 30 is opposite over adjacent. Now if you ponder on this a little bit, you'll see the connections too. Sine of 30 is half, and cos of the complementary angle is half. So complementary angles have the same values, which means sine of 10. Punch it on the calculator. What is sine of 10? What is sine of 10? How much? And now do cos of 80. Same thing?
Yeah.
Complementary angles have the same values for sine and cos. You get it? So you can see here sine 30 is half and cosine 60 is half. Sine 60 is root 3 over 2 and cosine 30 is root 3 over 2. So it is just like that. And here tan 60 is root 3 and tan 30 is 1 over root 3. It's also easy to remember because tan of 30 is a smaller value and tan of 60 is supposed to be a bigger value. So definitely 1 over root 3 is a smaller value. So these are special angles. So you know all of them basically now. So if you have 0 or 30 or 45 or 60 or 90, you can just look at these two charts and just pull it up. For other angles, that's where you need to use your calculator. So if I tell you what is 79, sine 79 degrees, you have to use your calculator. But understand this, sine of an angle, the range is from 0 to 1. It can't go anywhere more than 1. Cosine of an angle also goes between, let's say, 1 and 0. It goes the other way. Sine 0 is 0, sine 90 is 1. Cosine 0 is 1, cosine 90 is 0. So everything is between 1 and 0. Tan of an angle goes from 0 to infinity. Okay. Try to put what is tan 99, oh no, tan 89.9999999. Put 10 nines after the decimal point. Tan 89.999999999.
E to the 5.729
To the power of 11. Such a big number already. So the more and more you actually put those nines, you will see it's going higher and higher power. And when it is exactly tan 9D, that's when it goes to infinitely big number. Okay, that's infinite. All clear? You will need to use these things as we process. You can't always depend on the calculator. Now coming back to the sine square theta plus cos square theta. Sine square theta plus cos square theta is supposed to be 1. And it's a simple proof. Take a right angle triangle. That's your angle. I'll call A, B, and C as the three sides of this right angle triangle. What is sine theta? So basically, this is what I'm doing. What is sine theta? A over C. And then when you square it, it becomes A square over C square plus, what is cosine theta? B over C. So it becomes B square over C square. Now take C square common. What do you have on the top? And what is A square? This leg square plus this leg square. C square, hypotenuse square. Every trigonometric identity has a proof. It has got a proof. So you should know that also. Like, I know some of you know the trigonometric identities, but the proofs are here. And this thing can be rewritten in different ways. Look, sine theta, sine square theta is equal to 1 minus cos square theta. That is a trigonometric identity by itself. And everything is coming from here. And therefore, what is sine theta? Is equal to square root of 1 minus cos square theta. These are all coming from this same equation. Same way, cos theta is going to be root of 1 minus sine square theta. So there are a lot of trigonometric identities that are pulled from simple things like that. So knowledge of all these things will really help you, even in physics. Because sometimes in physics you end up bumping into this relationship, or sometimes you may need to get rid of the sine and bring in cosine. So this is the way to do it. If you want to get rid of the sine and bring in cosine into your equation, then that's the way to do it. All right, I'm not going to go on with trigonometry. It's a very interesting chapter. But we have to put limits to where we are going. All right? And so, how do you apply this? How do you apply this, in a simple way? Like, I'm standing at the base of a building. It's a tall building. How do you measure the height of the building? One way of doing it. One is like you go to the top and then drop something from there, like a thread or something, or a tape, and then measure it. But the other one is you don't have to even touch the building. Here's a building. And you are down here. You're down here. You don't have access to the top of the building. So since you don't have access to the top of the building, all you can go to is to the base of the building. Now what you do is walk away from the building a known distance. Walk away from the building a known distance. Like, walk far away. Like, 400 feet or whatever height you want to measure. Move. Let's say you moved a distance of 80 meters. You moved a distance of 80 meters. You came far away from the building. And then once you came far away, then what you do is you take something like that, a stick, and aim it to the top of the building. You know how to aim, right? If I have to aim at your eyes, I can aim like that. So aim at the top of the building. Once you aim at the top of the building, hold it still. In the sense, like, fix it here and fix it here. Keep it. Maybe you can use the help of two trees or two plants and keep it on the plant. Try to orient it, or just two supports. Do whatever you want, but I need this thing to be oriented perfectly to the top of the building. So once you orient it perfectly to the top of the building, you can do it from the bottom or from the top. So once it is oriented, the meter stick is oriented like that. So you are orienting it in such a way that it is aiming to the top of the building. Now what you do next is, there are two different ways of doing it. Let's go by the angle way. There are two ways of doing it. One is by similar triangles. So once you keep it like that, you know this is a meter stick. So it's 1 meter. And you can drop a perpendicular and then measure that height. So this height to this distance is the same as this height to this distance, which is 80 meters. right? That is a similar triangle approach. But suppose I could actually use a protractor and measure this angle. And if I got the angle measured as, let's say, 43 degrees, I measured the angle and it was 43 degrees. What trigonometric ratio connects H and 80 and 43? What trigonometric ratio connects tangent? So you take tangent of 43 is equal to H over 80. H is 80 tangent 43. Punch it on your calculator now and get the answer. 80 tan 43. Every time make sure it is in degrees. 74. Yeah, that's right. 74.6 meters. Right. 74.6 meters. That's exactly the height of the building. You didn't even touch the building, but you got the height of the building. This is purely a trigonometric approach. As I said, you can also use similar triangle approach, right? Okay. Any questions on this so far? After some use of these, after some use of this, you should be able to improve your speed on this, and you should be fine. Now back to our kinematics. All right. Pay real attention to these things, and once you pay real attention, kinematics will be absolutely interesting. Take it more like puzzles, and you'll be very comfortable with this chapter. And if you don't pay enough attention, that's where you have a lot of gaps, and you will struggle every step. So very, very important. Pay attention. So, so far in kinematics, what we did was we found out distance, displacement, and speed and velocity, and the various types of speed and various types of velocity. Those are the things that we did so far. Now let's go explore this more. Connect it to real life things like moving things. So most of these movements can be graphically put forth. So if there is a car moving in a certain way, I can plot a graph for the entire motion of the car. And that one look at the graph will tell you everything what the car was doing. Okay? But you need to put it right. A graph, you need to draw it in the right manner, and every stroke on the graph has a sense, has a meaning. So you should attach to it. The first graph distance time graph. On the x-axis is the time graph, time axis, and then the other one is the distance time graph. You know what is distance, right? Okay. Now I'm going to draw some lines on this, and you tell me what does that line represent. The line that is drawn represents what? Okay. Now what is this line on a displacement time graph? Yes. Standing still. This means at rest. This line implies at rest. So make a bigger graph. You have so much, you're going to put in so much. I'm going to draw so many lines on the same axis. So draw a bigger one. So you'll have so many lines, and each one will have some representation. You can write the representations right there. So this means at rest. What does this mean? Say it again. Uniform speed. Constant speed or uniform speed? Correct. That is uniform speed. It tells you and why do you say it is uniform or constant? Because it has got a constant slope. It's got a constant slope. So you can write that aspect immediately down. Slope of distance time graph gives what? Speed. That's a very important conclusion that you're going to get from here. So slope of a distance time graph gives you speed. And the slope is the same everywhere. That's why we call it uniform speed or constant speed. Get it clear? What is this one? What is that line supposed to represent? Does it have, read this again. That's also uniform speed. That is also uniform speed. That's also constant speed. Because just follow this. Slope of the distance time graph gives you speed. Is this a uniform slope? Then nothing to worry about. It is a constant speed. So what is the difference between this constant speed and that constant speed?
That one's going faster.
This is going faster, so you can write that down. That's going faster. What else do you know about this line? Yes?
It started going at a certain speed.
Slightly above.
It starts off already at a different distance. That means if I'm standing here, this one says starting point is this. Let's say the origin. Starting point is right here, and then goes to the constant speed. Whereas this means it is not starting from here. It's already covered some distance and it is here right now. So when the time is 0, it's not at its original location, it is somewhere else. And then it is going on. Right? You understand? So this line is constant speed faster starting from a certain distance. So each stroke on the line has a meaning and you have to pull that meaning out. That's basically the idea. Now what is this line? We have not touched the definition of acceleration yet, so I'll say increasing speeds. For the time being, increasing speeds. Okay, why do we say it's increasing speeds? Because, yeah, what is the slope here? Small, and the slope here? Bigger. You can see the slope here is small, slope is bigger, slope is bigger, slope is bigger. When you have a curve, how do you find the slope? You find the slope of the tangent at that spot. When you have a curve, that's what you do. So if you want to find the speed at this instant, in other words, called instantaneous speed, right? If you want to find the speed at that instant, at this time, then all you do is draw a tangent to that line. You know what a tangent is? A line that touches only at that point. Draw the best tangent to that point, and then find the slope of that. Then find the rise over round. You can draw a line that is longer. The tangent can be longer. Better to be longer. If you draw a short tangent, it may be involving a lot of errors because the precision will be small. Right? Instead of measuring a few millimeters here and millimeters here, if you measure in centimeters, then definitely you're having less chance of error. All right, so this is how we find the instantaneous. You can write that down. Instantaneous speed is found by taking slope of tangent drawn at that instant. So you're going to take the tangent of the curve drawn at that instant, and you find the slope of that, you'll get instantaneous speed. So how do you get an instantaneous speed from a graph which is actually continuously changing a tangent? And if you do the tangent here, well, it is not changing at all anywhere. Whether you draw the tangent here or here or here, it's going to be the same thing. That is why it's called uniform speed or constant speed. What is this line representing? What is that line? So let me write this down. Here, this is increasing speeds. And this is decreasing speed. Why do you say it's decreasing speeds? Because it is changing its slope. Starting from the highest slope, it is changing. It's slowing down. And it becomes horizontal. What is the slope there? 0. This is horizontal, which means it is 0. See, this is horizontal. That means 0 slope, which means 0 velocity, which means at rest, right? Here it is horizontal also, which means the highest speed and then applying brakes and finally comes to a halt. A horizontal line on distance time graph simply means coming to a halt. What is this line representing? What is that line representing?
Constant. It's decrease.
Constant slope.
But constant decrease.
Just coming back. Just think about it properly and then give me a solid answer. Yes.
Oh, well, if it's constant, I would say velocity, but it's coming back at you.
No, we're not talking velocity. We're talking about speeds only. Yes. Coming back to the starting point. Well, the answer for that is this line cannot exist. How can you undo a distance that you already done? Can you undo a distance you already done? You are this far, and as time progresses, the distance becomes 0. No way. You cannot undo a distance that you already covered. You can make it worse. If you move an inch, you're making it more. Distance does not have a sense of
direction.
So, for example, if I'm standing here and you tell me, can you move by a distance of 1 meter? You're telling me, move by a distance of 1 meter. And then I say, all right, I'll move 1 meter. But accidentally, I didn't move 1 meter. I went 2 meters. And then you remind me and say, oh, I told you to move only 1 meter, not 2 meters. Oh, okay, sorry. How many meters did I move? 3 meters. I cannot just make it one back again. I'm doing it worse. If I stand there, it is still 2 meters. I'm close. But I made it worse by coming back because it is 2 meters plus 1 meter, 3 meters. You cannot undo a distance. Distance graph cannot dip down. So if you look at a distance graph anywhere, the graph only can climb. So a distance time graph, the distance time graph cannot come down. So you can actually see the line going like that, stopped, and again climb up, and again stopped, and again going like this, stopped. It will never dip down. Whatever you do, it's going to just keep increasing the distance. You understand that part? Whatever you do, well, if it's a horizontal line, the distance is staying there because you're at rest. But then now you moved, staying at rest. Again you moved. It will keep climbing, no chance of it coming down. So keep that in mind. If you see a distance time graph, no line downward, absolutely, yes.
What would be an example of one where you have a vertical line? Just does that ever happen?
Vertical line simply means it takes hardly any time for it to go up, which is, I mean, you can't have a perfectly vertical line, which means like if there's a complete vertical line, see this is not totally vertical. See, I tilted a bit. A vertical line implies at the same time you're here and there. I mean, that's not possible. You can't be at two locations at the same time. So that's why it may be a little later. That's fine. That is possible. Like if it is at 5 seconds you're here and 5.01 seconds you're here, that's possible. Because there is a time between this journey. Right? Even if you go at the speed of light, still it takes time to move from one spot to the other spot. So totally vertical line is not possible. Yeah. Any questions on this distance time graph? Okay. Now let's do a slight change. Displacement time graph. Some books actually give you, instead of displacement, they will actually say position. So a position time graph and a displacement time graph kind of implies the same thing. Okay? Because when you're saying position, you're actually saying the position with respect to some spot. All right? Yeah. If I'm standing here, that is the origin, that is the zero position. And if I say here is the other position, 1 meter away. In other words, it's a displacement of 1 meter. Right? So yes, you can actually sometimes see position time graph or displacement time graph. If you're just drawing a position time graph, they will use X or Y or whatever. They'll use X if you are moving horizontally. They'll use Y if you are moving vertically. Just like graph. So yeah, displacement time graph. What does this line represent on a displacement time graph? Now you should be able to do it faster. What is it? No velocity, no change, which means at rest. Zero velocity, zero slope, so it's at rest. What is this line? I'm drawing the same lines. No? Uniform velocity. So this is uniform velocity. And what is velocity definition? It is the change in displacement over change in time. So that's why it's called a velocity, because we are talking about not distance but displacement. And the other line, I'm drawing the same thing. Okay, that one, it's constant velocity starting from a positive displacement. It's starting from a positive displacement. And the other difference between this line and that line is this one has got more slope, so therefore it is going faster. So slope of displacement time graph gives velocity. And what does this line mean? Increasing velocity. So just flip the words, increasing velocity. And this one is decreasing velocity. decreasing velocity. And what is this? This one is negative velocity. See, negative slope. This, it's possible to have negative velocity, but no negative speed. Speed can never be negative because speed is a scalar quantity. So no negatives there, but velocity can be negative. Make sense? So this is negative velocity, constant, negative constant velocity. Why do you say that? Because it is a constant slope and it is a downward slope. So any line that is like this, zero slope, positive slope, negative slope. Right? You're familiar with those things. All right, so that's a negative slope. What does this line represent? What does that line represent?
Constant velocity starting at a
Negative?
negative displacement.
So this means it is starting with a negative displacement, let's say negative 10, negative 20, and negative 30. It starts with a negative 30 and then moves with a positive velocity. You get it? So an example will be, this is our reference point. Let's say the car. The car is starting from 30 meters behind and then moving in the positive direction. We use the same conventions for positive and negative, just like in a graph. Positive x-axis, negative x-axis, right? Positive y-axis, negative. We just use exactly the same convention so you don't mix it up. So this line implies the car or whatever it is was having a negative displacement to start with. And then it is moving in the forward direction, positive direction. So it starts coming this way, and at this time it is right there. But it's not stopping, it's just on its way, and then it's on its way. Make sense? So that is the displacement time graph. And the meaning of those lines at every spot, sit straight. Sit straight. Okay. Both of you. Perfect. Every stroke on the line has some sense. And you have to keep that sense in mind and then draw it. Okay? Any questions on this? What is this line? It is at a negative displacement and it's not moving. Right? So many things can be seen from a graph like such as displacement time graph. Now coming to velocity time graph. Velocity time graph. These are velocities. On a velocity time graph, what does this represent? Uniform velocity. What does this line represent? So let's say 10 meters per second, 20 meters per second, 30 meters per second, and it's minus 10, minus 20 meters per second, minus 30 meters per second, and the time 1, 2, 3, 4, 5 seconds. So on this graph, that means uniform velocity. What does this line mean?
Uniform velocity.
What's the difference? That's uniform velocity and that's uniform. What's the difference? This is a negative velocity, so this is uniform negative velocity. And that was a positive velocity. That line. It is increasing velocity. Is it a constantly increasing velocity? So that's why we call it constant acceleration. So basically, what is acceleration? It's a rate of change of velocity. You can write that down. Acceleration is a rate of change of velocity. So acceleration is change in velocity over change in time. Acceleration is change in velocity over change in time. And how do you find the acceleration? Is the rate of change of velocity, delta v over delta t. This part of it is delta v and this is delta t. So slope. So slope of velocity time graph gives acceleration. Slope of velocity time graph gives you acceleration. What is this one? What is that line?
Something just faster acceleration.
Greater acceleration. So constant higher acceleration than this. It's a constant higher acceleration because it's a greater slope. Now what is this one? What is that line supposed to be?
Constant higher acceleration starting at 10 meters.
Oh, don't worry about the slopes part of it. I mean, it looks like it's the same slope, right? Looks like these two are same slope. So don't worry about the values. This is constant acceleration, but what is unique? It does not start from zero velocity. It starts with a velocity of 10 meters per second. Starting velocity is 10 meters per second. It's not starting from rest. It's already moving at time zero. At time zero, it was moving at 10 meters per second, and then it continues to accelerate. Start constant acceleration starting with an initial velocity. Constant acceleration starting with an initial velocity. What is this line? It's a constant deceleration. Deceleration, constant deceleration or negative acceleration. But we don't call it deacceleration. That's not the word. Either call it deceleration, which is the same as negative acceleration. So this slope is negative, and that's why it is deceleration. Got it? Any stroke on the line will make sense. So if you're drawing a line like this, what is that? What's the acceleration of this line? 0. That means it's not accelerating. If something is not accelerating, its velocity must stay the same. Because change of velocity is basically what causes the acceleration. So if something has 0 slope on a velocity time graph, it is not accelerating, which means it can stay at the same velocity. But this one is staying with a velocity of negative 30 and stays negative 30, which means it's going backward with a negative 30. I mean, backward with a 30 meters per second. Right? Got it? And it is not changing. It is acceleration of 0 and it's a constant negative velocity. Now I'll give you a question. I'll give you a question and answer the question. If I take this marker and throw it upward, if I take the marker and throw it upward, I'm throwing it upward, okay? I'm throwing it upward and it comes back to my hand. Can you draw a velocity time graph for it? No need for numbers. Just draw a velocity time graph for this scenario. I throw it up and then it comes back again. You do it on your books. And I'll come and check if there is